today's lesson is 9.5 sine and cosine ratios. And again, today we'll explain sine and cosine ratios and find sine and cosine ratios and solve real world problems. So in our quick notes, this is what we learned last week. We're going to look at sine and cosine. So we're going to take and we're going to draw a triangle in the middle here. We're going to label our right angle, because that's the most important. Helps us find all our bases. Alright. So basically, the first thing I need to know is this is a hypotenuse. Remember, we can label that as HPO. And label my angles A, C, and B. Alright, and on this we're going to put sine A here, and then on this side we're going to put cosine A here. Okay, so we're looking at this angle right here. Okay, so this is where you can see the difference. So basically we know that A down here, this is your adjacent, and going across is your opposite. So when we learned last week, we learned that sine, right, was opposite over hypotenuse. And that was the first part of SOHCAHTOA. So it was SOH. I like to write it as SO over H like that. Okay? So basically, you have your opposite side, which is BC, is over your hypotenuse, which is AB. So you're basically finding your sine for A, but then you're also going to come over here and do your cosine. And last week we learned that cosine was your adjacent over your hypotenuse. Alright, so basically that's the SOHCAHTOA, the C-A-H of SOHCAHTOA. Alright, I like to write it as C-A over H, so that I know. So if I'm looking at the adjacent, my adjacent is AC over my hypotenuse, which is AB. So these are much easier to solve than what we just did with tangent, because there's not really any movement with x like we did in the last one, where we had to take and move. So last week you did a whole bunch of practice on just picking the sides and making sure that you had this ratio and making it into a decimal. So, alright. So let's go down to example number 1. And this one is going to be rewriting our, step back, we're going to find the leg length. The exact same thing we just did in the other video, but now we are taking and using sine and cosine. So again, I'm going to draw my triangle in the center, because we're going to use the same triangle for both sine and cosine. Alright, so I'm going to draw this out. What you will notice is that I will have an X and I'll have a Y in this one. So I have 26 degrees down here. I have a 14 here. I have an X and I have a Y. So So the first thing that you need to do is you need to make sure that you label it. If you don't label it, you're going to get it wrong. So I'm going to draw across from my right angle, label that my hypotenuse. Then I'm going to find my adjacent. So this is my adjacent at 26. This is my adjacent, which means when I take my 26 and I draw going across my triangle, this will be my opposite. So the first thing that you need to do is you need to write the ratio. We know that sine is equal to opposite over hypotenuse. So my sine, I'm looking for the degree. Well, what is my degree? My degree is 26. This is going to be sine 26 degrees is equal to my opposite, which is x, over my hypotenuse, which is 14. So again, we're looking at getting the x by itself. So this one's much easier because I just have to move the 14. Where in tangent, I had to move the x and then I had to move my tangent back. This one, I just have to move the 14. So remember, this line means divide. So I'm going to take and remove my 14. So I'm going to multiply both sides by 14. Alright, which is going to give me 14 times sine 26 degrees equals x. I'm going to use my calculator, and again, I'm going to use my Desmos on my phone because I just like the way it does it much better. It's easier. Alright. So I'm going to put in 14. I'm going to hit my times. I'm going to hit sine and then 26. And that gives me 6.13. And again, I'm only going to the first decimal. So this means that I'm going to do 6.1 because the 3 is not above 5. And there is my answer for x when I'm looking at sine. So again, this one's much easier than what we just did with tangent. Alright? Because all you have to do is multiply it. Alright, so that was sine. So now we're going to come over here to cosine. And cosine, alright, is equal to, again, if we come back up here, adjacent over hypotenuse, adjacent over hypotenuse. So first thing I'm going to do is cosine. My cosine degree is 26. Filling that in first. And then I'm going to take and do my adjacent, which is my y in this case, over my hypotenuse, which is 14. Alright. And again, I've got to get my y by itself. That's what I'm doing, getting my y by myself. So all I have to do is I have to take this 14 and move it. And we know that this line right here means divide, so the opposite divide is multiply. So I'm going to multiply both sides by 14, okay, which cancels out here and leaves me with 14 times cosine 26 degrees equals y. So I'm going to do it again on my phone calculator, on my Desmos scientific calculator. I'm going to put in my 14 times, and this time we're going to hit cosine 26. It's going to give me 12.58. Alright, so I've got 12.58 equals my y, but I've got to look at this digit right here. It's above 5, so that means I've got to round up on my 5 to make it a 6. So my answer is actually going to be 12.6 equals y. you could also do, clear all, you could also hit your ABC. And actually you don't have to hit the ABC because this one's not. So you just literally just do exactly 14 times 26. All right, we're gonna do a try it. On this. So again, we're using one triangle. I'm going to draw the triangle first. And put my right angle. And then I've got X. I've got 53. 53 here. I've got Y here. I've got 35 here. Alright, I'm going to have sine equals opposite over hypotenuse. And then you're going to have cosine equals adjacent over hypotenuse. So what I'm going to do is with this try it, you're going to upload a picture of your try it with your answers. And I'm going to check and see if they're correct. So go ahead and do them, and then you're going to go on and you're going to upload your answers so that I can see that you're doing them.